they'll cover everything. 1.2 is a lesson about sets. If you have trouble with 1.2, then it's going to make 1.3 and 1.4 dang near impossible. So 1.2 is going to be a lot of definitions. It's going to be a lot of reading. It's not going to be a lot of doing actual math, but it's going to lead us into all of our math that we're doing tomorrow and the day after that. What we're going to talk about is something called sets. We're going to start off by talking about what a set is and then different ways of writing sets. A set is just a group of things. So for example, like we could be a group of things and we could be a set. We could be the people in Mr. Kennedy's Math 30-2 class, and we could be a set. Usually in math we're talking about numbers, right? So that makes more sense. There's three different ways that you'll see sets written. The first way is probably, the first two ways are the most popular. The third way you won't really see much of. The first way is if you just list them out like that. So this sentence right here would say the set A has the numbers 1, 2, 3, 4, 5, and 6 in it. So it's actually listing the items within the set. That's a pretty simple way of doing things. The second way of doing things is usually when you have a list that's a little bit too big to write out. So the second way is just basically a description but inside of the curly brackets where your list would have gone. So in this case it says set A is natural numbers less than 7. So any natural number less than 7 would be a part of that set. Natural numbers are counting numbers, so it doesn't include the number 0, and it'd be anything less than 7. So the things in this set would be 1, 2, 3, 4, 5, and 6. These two sets are actually the exact same thing, it's just two different ways of describing it or writing it out. The third way to do a set is using set builder notation. You guys used to see this when you did domain and range on questions. That's where you usually see set builder notation. But it's still the same idea, it's just listing the things that are within the set. This little bar means such that. Okay? So when you see that bar, it means such. If you were to read this third thing, it would say set A is X such that X is less than 7. And X is an element of the natural numbers. So if you were to read that entire thing, it would tell you X could be any number less than 7 as long as X is a natural number. So the things that would be in this set would be 1, 2, 3, 4, 5, 6. Just like the sets above it. So really, all three sets are the exact same. It's just three different ways of talking about that set. Make sense? The most popular ways you're going to see in this unit are these. We probably won't see any set builder notation. Might throw one in there if I'm just really upset with you guys or something. Alright. Another thing you need to know about sets is you'll often be asked like how many things are within a set. And that has a little bit of special writing. You need to write it as M, bracket, A, bracket. That would mean the number of things in set A. So that's what that means. Or the number of members of set A. In our case, I think this is a little bit off the page for you, isn't it? For some reason format is funny. It doesn't look the same as mine. But you should have M bracket A bracket equals 6 somewhere on your page. And what that is saying to you right here, I think yours like starts over here, it's M, and then bracket A equals 6. Yeah, okay. I just moved it over. This is saying the number of members in set A is 6. There's 6 things in the set. That's all it's telling you. We need to do that a little bit. Every once in a while you'll see that, or you'll see questions like that. So you need to understand that when you see M of something, it's asking for the number of members. All right, we're going to try this. So we're going to try a question, just see if we understand what's going on. The first question is, consider the following two sets. So there's set P and there's set Q. Set P is all even natural numbers less than 11. Set Q is odd natural numbers less than 11. In the bottom, they want you to list the elements of each set. So the things in set P would be even natural numbers less than 11. 2, 4, 6, 8, and 10. Those would be the items or the members of element. Sorry, those would be the members of set P. Yeah. They have to be curly brackets. Yeah, you'll always see curly brackets. That means is a set of. If you suck at drawing curly brackets like myself, I just squiggle. And it's very clear that I'm trying to do something that's much nicer. And then some of you guys are able to write like perfect little curly brackets. I'm just not one of those people. Okay, try for Q. So what's in set Q? I want you to write it out on your own. The things in set Q. Odd natural numbers less than 11. So write all the members of QO. So odd numbers that are less than 11 would be 1, 3, 5, 7, 9, and we wouldn't include 11 because it's at less than 11. So it doesn't include the number. How many things are in set P? 5. We would write that the number of things in P is 5. That's what this would mean right here. The number of members in set P equals 5. Do the same thing for Q. The number of things in set Q is 5. All right. Types of sets. So there's a whole bunch of different types of sets. The first thing you need to know is something called a universal set, which you can't see. It says universal. Universal set. The universal set is like the all-encompassing set that includes everything you're talking about. So for instance, if I wanted to talk about two groups in this class, there's a set of males and there's a set of females. And then within the class would be all the people in the class. That would be the universal set. Everyone in the class, because it includes every member of both sets that I was talking about. They have the definition here. It's the largest set, and it contains all of the elements. It contains all of the elements. Sometimes all of the elements might be in another set as well, and that's okay. But as long as the universal set contains everything, you're good. The next term you're going to hear a bunch of is subsets. So subsets would be a group within another group. Often we're talking about a set within the universal set. So for my exact example of there's females and there's males, and then there's everyone in the room. Females would be a subset of people in this room. Right? You are a set of people within the universal set of everything here. Yep.
Like a subset of subsets.
Yep.
So like got like boys and fur shirts.
Exactly. So then you could have a set within a set. So if I was talking about there's the set of females, and then there's the set of females with brown curly hair. So then that would be a group within the group. So it'd be a subset of a subset. And it could keep going all the way down into however many subsets. There's a symbol to describe subset. It's this symbol here. It's like almost like a C. Almost looks like a C, but not quite. Yeah. If you see that symbol, it means subset. So in the example here, it says A is a subset of B. That's how you would read that. That means A is contained within B. Anything in A is in B. Another set that we talk about, we don't really talk about it much, it's called an empty set. So if this was our universal set, our classroom, and then we had a set of all the people in here who are dogs, there would be nobody in that set. One. There'd be nobody in that set. And that's called an empty set. So sometimes there will be things that are empty. Another way, probably a better example, is if we took the set of males in this room, and then we did the set of males with blonde hair in this room. And none of the males in here have blonde hair. So that would be an empty set. There's nobody in that group. Empty set is shown with this symbol. It's like a 0 with a line through it. It's more an O than a 0. It's an O with a line through it. Again, we don't talk a lot about empty sets, but they do happen every once in a while when you really start to do kind of cross sections of sets in the future. Down here, the way we would write it out is we would just say A is empty. That means A is an empty set. There's nothing in set A. Finally, the last one we talk about is the complement of a set. And that's what we talk about a lot. The complement of a set is the opposite of a group. So it says a complement of a set is all things that are not in a set. Example, A would mean all elements, A apostrophe. That little apostrophe means complement of. So A apostrophe would mean all elements not in set A. Sometimes you might hear it referred to as A prime, just because sometimes that's how people read it. So they read that apostrophe as the word prime. An example of that. So if we were talking about this school as an entire universal set, and then there was the set of us within the room, we would be set group A. Everybody not in this classroom would be A prime. Because that would be the group of people that aren't in our group. So it's the complement of the set that we're talking about. There's a lot of examples. We're going to do a bunch of examples. Tomorrow we're going to do even more examples. And the day after that, we're going to do really big, even more complex examples. What's important is that you just understand definitions today. We're going to do some examples of it. So we have an example. They've given us 3 sets. Set A is even natural numbers less than 20. Set B is natural numbers less than 20 that are all divisible by 4. And then C is the set of prime numbers that are less than 20. My suggestion is when you get a question like this, where they've described what's within a set, it's honestly much easier if you list out what's in each set. Because it can be sometimes hard to think of all of them. So what I would do is I would go to each of these sets and I would write them out as lists. So I would say the things in A, even natural numbers less than 20. So that's going to be all the even numbers. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. And that helps me just like visualize what's actually inside that set rather than having to depend on thinking about even numbers less than 20. I'm going to do the same thing for B. So B was natural numbers less than 20 that are divisible by 4. So numbers less than 20 that are divisible by 4 include 4, 8, 12, 16. Those are all the numbers less than 20 that you could divide by 4. Group C is prime numbers less than 20. A reminder of prime numbers. Prime numbers are numbers that can only be divided by 2 things, and those 2 things have to be the number 1 and itself. So, for example, the number 2 can only be divided by the number 1 and the number 2. 3 is also prime. 5 is prime, 7 is prime, 11, 13, and 17. Oh, the number 19 is also prime. We're going to notice this. So those are prime numbers less than 20. Again, if it takes you a little longer to draw those out, that's okay. Like, you don't need to know those off by heart. If you need to take your time to figure out the numbers divisible by 4, that's not a big deal. Question A. What would be a suitable universal set? What would be a good universal set for this question? We could say all numbers, but that would be huge, right? Like, we could say numbers, which is true. Like, everything we've talked about is a number. I mean, those are huge numbers. So what's a little bit more narrowed down universal set? Oh, that'd be a perfect universal set, because that's all they ever talk about is natural numbers less than 20. So a good universal set for this question would be natural numbers sign for numbers so lazy. Natural numbers less than 20. That'd be a great universal set. There's no wrong answer there, as long as whatever universal set you chose included everything that we've talked about. So if I said that the universal set was even numbers, that wouldn't work, because that wouldn't include some of the things we do need in the universal set.
When writing out your universal set, do you just write it on words like that, or
Nope, you can just write it out like that. If anyone's ever talking about natural or a universal set, you can just talk about it, write it out. Alright, list the elements of the following sets. So, what all is in set B? Well, we wrote it over here. It's 4, 8, 12, 16. Question B, what's in set C? Well, we've written it up here, so we can just copy it in. 2, 3, 5, 7, 11, 13, 17, 19. Question 3, you're not going to quite have enough room to write it in, so we're going to have to write it down below. But what is that asking me? It says A prime equals. It's asking me what numbers aren't in A. So what numbers are in these 3 sets, but not in A? Are any of the things in B going to not be in A? No, these are all in A, aren't they? So we look up here at group C. What numbers in here are not going to be in A? 5 would not be in A. 3 would not be in A. 7, 11, 13, 17, 19. All of these would not be in A except for the number 2. So our answer to what would not be in A, our answer would be 3, 5, 7, 11, 13, 17, and 19. That's items that are not in A. Question C. For each of these, we're going to put true or false. To be able to do these true-false questions, we need to know what the question's asking you. So, it's just a bunch of letters and symbols, correct? This is B, and then it's that sideways looking thing, A. What does that mean? It means subset. So B is a subset of A. That means everything in B is also in A. Is that true? Is everything in B also in A? Yeah. That's true. Everything in B is in A. Number 2 says everything in C is in A. So everything in group C has to be in A for that to be a true statement, which is false. Not everything is in there. The number 2 is in there, but that's all. Question 3. That says A is a subset of B. So things that are in A are also in B. Some of the things are, right? Like 4, 8, 12, and 16 are all in B, but not everything in A is in B. So that would be false. When you see something like subset, that means everything is in there. In this case, that's not true.
So it would matter on the
It matters. The order it's in does matter, yeah. Like when it's written like that, the order matters, yeah. The fourth one. This one's a little trickier. This says everything in C is a subset of everything that's not in A. That's A complement. So everything that's not in A. What are all the things that are not in A? Well, we wrote that right here. Right? These are all the things that are not in A. 3, 5, 7, 11, 13, 17, and 19 are not in A. So is everything in group C inside that group of not A? It's really close. What's it missing? It's missing the number 2. The number 2 is in C, but the number 2 is not in not A, so that would be false. But you can see that these questions could get really big and confusing pretty quick. When you start talking about groups and then not in groups, and then groups within not in groups, it can get a little confusing quickly. So my suggestion to make it easy is often to write out the sets like that, and then you can look at them and compare them a little bit easier. That's the first part of learning about sets. So there's another whole part of this, and that's when sets start to partially cross each other. Like, for example, in that last question, there was a lot of things in common between C and not A, but there wasn't quite perfect, was it? So they came up with a few more things, and the first thing they came up with, intersections of sets. So the intersection of sets is often when you say the word and. So if I were going to say, in this classroom, we have girls and we have people with brown hair. So that would be anyone that is a female with brown hair would be in that group. It's called an intersection of two groups. Here, they show that the symbol for and is this one. It's like that other sideways symbol we had, but now it's facing down. The way I like to remember it, this symbol looks a lot like the letter A. And I like to think of it as A and. That's how I know which one it means. So that's my trick to remembering that the upside down thing means and. The way you will see it written is like this. That would mean something is an element of A and B. That's how you would read that sentence. The union of sets. I think this one's probably the hardest one, in my opinion. The union of sets means or. So this thing is now an upside down and symbol. I don't really have a cool way of thinking that that means or. If you were to read it, it would go, something is an element of A or B. It doesn't have to be in both. It just has to be in one or the other, or it could be in both. So when you talk about the union of sets, which is this symbol, it's talking about a lot of things. It's including anything from set A, and anything in set B, and anything that's in both sets. The disjoint sets is two sets that have nothing in common. So if we were talking about this in layman terms, and I said you have the set of males in here, and you have a set of females in here, those would be disjoint sets. Nobody's in both things. Okay? If I had people who are blonde versus people who have red hair, that would be disjoint sets. You don't have anyone who's blonde who's also in the redhead section. Except for those people with red blonde. Yeah. But you understand what I'm saying is it's two sets that aren't connected in any way. They call that disjoint. And it does happen every once in a while. There's no symbol for it, you would just call it disjoint set. How this looks in questions. So, we've got all of our sets written out here. That says consider the following sets, and then there's a bunch of questions with it. Set A is the natural numbers less than 20 that are divisible by, set A. Set A is natural numbers less than 20 that are divisible by 3. I suggest when you read something like that, see if you can't write out what's in set A. It'll make your life a little bit easier. So I'm going to list those things out. You need a little bit of room. This is actually going to do them. 3, 6, 9, 12, 15, and 18. That's all the things in set A. Set B is natural numbers less than 20 that are divisible by 5. Again, write them out. It'll make your life easier when you start comparing. So divisible by 3, okay, divisible by 5 would be 5, 10, 15. That's all the things in set B. Set C, numbers that are divisible by 6. Write it out. 6, 12, 8. Those are your 3 sets. I mean, you can talk about them like we are right now, or you can list them out. Listing them out makes them a heck of a lot easier in my opinion. Now, you start getting questions about what to do. The first 2 questions are a little bit easier. The third question is how you can see how things can get a little bit harder and challenging. You need to know what these symbols all mean. So this first question, 1i. Set A and set B. So that's saying what is in A and in B. If you look back at your sets, what's in set A and in set B? It's the only thing. So the only thing that would be in set A and B would be 15. And I would write it out like that. That's technically saying this set is the number 15, so anything in there. If they were saying what's in there, you could just put the number 15 and that'd be fine. You'd say like, what is the member of it? Just 15. Question 2. If you were to read this aloud, is a set of A or is a set of B? So that's going to be all things in A, all the things in B, and all the things that are in both A and B. So in our case, it's going to be a lot of things. That's going to be 3. I'm just going to go up numerically. It makes my life a little bit easier. The next highest number would be 5. That's in set B. And then 6 and 9 would both be in there. And then 10 would be in there. 12 would be in there. 15 is in there in both sets. You only have to write it once. So this guy is in both sets, but you only have to write him out once. You don't have to write it multiple times. Those would be all the things that are in set A or B. Everything, basically, yeah. Everything in both. The third question, a little bit trickier because now they start using that prime. This thing says items that are not in A and they're in B. So what items are not in A and are found in B? So let's try writing out the things that are not in A. Because again, that's how you make this easy for yourself, is list out the things that are in each set. What numbers are not in A? Yeah.
4, 5, 7, 8.
You're right. What are not in A but in the other sets?
5.
Yep. 5 is not in A. 10 is not in A. And that is it. So those are the things that are not A. So what is not A and found in B? 5 and 10. And that's all. It turns out to be everything that's in not A. The best way to do it is list out the things for each set, and then you can just look at the numbers, and your life is easier. If you're trying to think what's not here, but in here and in here, that's going to make things harder.
If there were ever a question where there was no answer, would you just leave it blank?
Yeah, so if it was like, what is in set? Oh, is that a good question? Yeah, what is in set A and B and C? Nothing is in all three of these, so that would be when you use your empty set symbol. It'd be an empty set. Alright, try this. Write sets equivalent to the following sets. So we're going to see if we can come up with writing out sets that would have the same number of things. So this question says, what's in B and in C? What things are in B and C? There's no matches, right? Nothing is in B and nothing is in C. So this is a perfect time to use what Sarah just brought up. The things in B and C, nothing. That's an empty set. What's another empty set you could think of? That's what they're asking you to do. So what would be an equivalent thing that would be an empty set? Yeah. Things that are in C and are not in A, that would be a good one. So things are in C and in not A. The things that are in C are 6, 12, and 18. The things that are in not A are 5 and 10. So there would be no intersection there. So that would definitely be an empty set. These are equivalent. They have the same things inside of them. That's a tricky one that you came up with. I like that. So the things that are in C are 6, 12, and 18. And you're looking for things that are in C and in not A. Things in not A were just 5 and 10. Nothing is in both of those, so nothing's in their intersection. This one says, what's in set A and C? So things in set A and in set C would be what? 6, 12, and 18. What's an equivalent set to 6, 12, and 18? Something you could come up with that would be the same thing. Sometimes it's tricky coming up with equivalent sets. You could do what? The opposite. You could do C and A. That would work, yeah. You could also do, what are the things in just set C? That would technically work. You could do, what are the things, just trying to think of what's that hard.
What are the things in B or what are the things in C?
Yeah, that's exactly what I was going with. Things that are in C and are in not B. So that's things in C that are not in B. Well, that would be 6, 12, and 8. Those would be equivalent sets. The last one, the hardest one, this is what's in A or C. So all the things in A or C are listed out. Green, so it's 6, 7, 1. All the things in A or C is 3, 6, 9, 12, 15, 18. Those are the things in A or C. What's an equivalent group to that? What are the things in? What are the things in A? That would work. This happens to be the exact same set as set A. It also happens, yep. You would just write set A. That would work. If you're looking to do some sort of intersection or union, I would say it's also the same things here in set A and C. Right? Those would be the, oh, I'm a liar. It's not the same thing. Take that back. Rewind that. Yeah, I was doing union in my head. It would be the same thing as A or can't even do not B. Struggling. That's a hard one. A would for sure work because those are the exact same. You could do things that are in. Oh, running out of ideas. Anybody have one? Might just be set A that's equivalent. That's where you get stuck, is sometimes you can't think of anything equivalent. Yeah, I think just set A is going to be our answer for that one. Can't think of any other intersection ones. All right. We've only dealt with single intersections or single unions or single disjoint things or single primes, but in reality, you could actually mix them all together. So question 3 shows you how these things can be combined. They add in a group here to make this a little bit easier, so they say D is even natural numbers less than 20. Again, I like to write them out in lists, make my life easier. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Those are all the things in D. I find it easier when they're listed. You don't have to do that, just advice. The first question says, what are the things that are in A and in B or D? So you need to know how to do these things in what order, because that's going to make a difference. And you're going to follow the same thing you've always been following in math, which is bed maths. So you're going to do anything inside the brackets first. So I'm going to try to figure out what things are in B or D. And I'm going to write that list out. So the things that are in B or D would equal, well, B was 5, 10, and 15. D was all even numbers. So basically, I'm going to have all even numbers plus 5 and 15. I had to rewrite mine a little bit off because I had to make it big enough. That's the things in B or D. D was all the even things. B was 5, 10, and 15. So all we had to do was add in the numbers 5 and 15 to get B or D. Now that we know what's in this group, we can try to figure out what's in A and this group. So what things are in group A and are in this new one that we just created? Yep, what things are in A and this group we just created? 6, 12, 15, 18. Those are the things that are the same. 6, 12, 15, 18. So you made the brackets first, you figured out what's in that set, and then you figured out what's in the big set intersected with that set. question 2. Again, there's brackets around something. So follow your bedmax rules. Do whatever in the brackets first, and then try to connect everything. So I'm going to start here. It says what's in A and B. That's how you would read that. What things are in A and B? 15. That's it, isn't it? So A and B. I really couldn't pay for him. A and B. 15. Now it's easier to ask yourself a big question, which is, what's in A and B or in D? Yeah, so it's going to be all those things in D plus add the number 15. You know. So yeah, you're right. It's all the things in D, so it's all this list, plus you have to add the number 15 in there. So write out all those even numbers, and then add the number 15 to it. That's going to be a long one. 2, 4, 6, 8, 10, 12, 14, 15, 16, 18. That's everything in D and everything in my A and B. All right, last one. We got complements on complements here, so this gets a little bit trickier again. We're going to follow our rule of doing inside the brackets first. So this thing says, inside the brackets, what's not in A and not in B? Yeah. What things are not in A and are not in B? Again, it might help to write out what's not in A. We already wrote it up here. So 5 and 10 are the only numbers in not A. Are 5 and 10 also not in B? They are in B. So the intersection between not A and not B would be no. There's nothing in that set. Not A had the numbers 5 and 10. Not B included a whole bunch of numbers, but it wasn't allowed to include 5 and 10. So now your job is to figure out what's the opposite of the null set. Now it's going to include everything. So if this was the null set, it included nothing, but now you want to do not in that set, then you would include absolutely everything that you could. So it would be all your even numbers plus all of these 3, 9, 15, and that's it. So if you were to write out that entire thing, it would be, let's start with the even numbers, 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16, and 18. Those are all the things that are not in the null set. Yep. No, that's good. You need to be that person. Someone's got to be. There's a 5 I missed it. Was there any other odd numbers I missed? So we figured out what was in the brackets, and then we did the opposite. If you can do questions like that, you're probably pretty set. That does it for all of our intersections, unions, and sets information. Tomorrow, basically, what we do is we take all this stuff, and then we start putting it into pictures. Okay, so it can get a little bit crazy. So it's important that you do this stuff, practice this stuff, and get good at it. If you look at your practice booklet, there's a whole bunch on this stuff. I suggest that's what you do. We have half hour to do that, so you should probably be done that practice booklet hopefully by tomorrow or close to done that practice booklet because there wasn't really that much in it.